All right, gang, so we're going to talk about inheritance again. Slightly different topic, though. Same business. The business is creating what's known as a parent class, so the superclass. Superclass is Java's term for it. Parent class, I believe, is C++'s term for it. You can kind of use them interchangeably because you consider the class that inherits from it, the class that extends it, the subclass, but is also known as a child class, right? Creating the same hierarchy. Maybe you like that terminology, a parent class and a child class, a superclass or a subclass. Same business. So what we're going to do is talk about something slightly different. The slightly different is that we're going to talk about abstract methods and abstract classes. Well, what is an abstract method? It is a method that has to be added to the child class, to the subclass. And since it has to be there, we don't even put a body for that method in the superclass, in the parent class. So we're going to come up with another Pokemon example just because I think that a lot of us can relate to Pokemon, and if not, oh well. Hopefully it makes sense as we go along. Alright, so we're going to create another class, except I'm going to call it just POK to differentiate it from the last one. This is going to be a lot less of a detailed example than the last one. So every Pokemon has a hit point, right? And I'm going to make it protected just so that we can say that every Pokemon, right? All the subclasses will be able to access that. Because if I made it private, then even the child classes, the subclasses, wouldn't be able to get a hold of that variable except through getters and setters, which is probably the right way to do it. But for the shortest example possible, I'm just going to make it protected. We probably ought to add getters and setters for it if the main class needed to access them. All right, so every Pokemon has a way to attack, right? So void attack, and maybe some kind of string for what it is attacking with, right? What kind of attack it is. But I'm going to stick the word abstract in front of it and a colon at the end of it. And what that means is that this method does not have a body. So anything that inherits from it has to implement the attack method, or else it is not a real Pokemon. I'm just going to call it Poke, short for Pokemon there. Since it has an abstract method, that turns it into an abstract class. Now, an abstract class is one that cannot be instantiated down in main. If I try to, I'm going to get an error. If I say Poke Pikachu equals new Poke, right? That's not going to work. It's an error because the Pokemon class, Poke, is abstract. Poke is abstract, cannot be instantiated. Well, why can't it be instantiated? Because it's got an abstract method in it. It's got a method without a body. How would we call Pikachu.attack if .attack doesn't have a body? So it's up to the subclasses to implement that method. And I'm going to get rid of that. That didn't work. Okay, so let's make a subclass. Now, it's not going to be abstract. Not to say it can't be, but in our example, it's not going to be. I mean, an abstract class can inherit another class. So we're going to say that class electric, an electric Pokemon, change my mind, we're going to make it a psychic Pokemon, extends the Pokemon class. But we're getting an error. Psychic is not abstract and does not override the abstract method. In other words, we have this method that we have to add in order for it to be a Pokemon. And we didn't. So it's not a real class. So if we didn't want to implement it, we'd add the word abstract in front of it. But we do want it to be a class that we can instantiate. We want to be able to create psychic Pokemon. So we have to implement that class. So here we go. We're not going to put the word abstract in front of it because we're actually going to give it a body. You know what, why don't we just call this public? Kind of forgot that. Or do you like seeing the word abstract in front of it? You could do that instead, right? Abstract, public, think you could do that. I like seeing the word public in front of it, so I'm going to leave all that alone. Alrighty, so public void attack, parentheses, string S in parentheses, semicolon. Except it's not a semicolon, we actually have to give it a body. So what are we going to do? We're just going to print some kind of message. It's a psychic Pokemon. So what kind of attack could a psychic Pokemon have? Well, I can't think of something, so right off the bat, I'm going to just make it system.out.println psychic attack, colon, excuse me, exclamation mark space, end quote, plus S in parentheses, semicolon. Right, so whatever was passed in there is our psychic attack. All right, we have provided a method for this abstract class. And we still have our little warning over here that says add override annotation. I'm going to go ahead and do that now. What that's indicating is that this is an implementation of a method that was defined in a parent class, in a superclass. It's called an override. An override is replacing a method that was defined in a superclass. Well, why do we want that little comment? Because if you have that comment there, but you get something wrong, like say, don't do this. Like I say, oh, by the way, I've decided that attack is going to take an extra int. Well, it's no longer overriding this method, right? Because it's got a different parameter list. So it's not an accurate override. That's what adding that keyword is. It's just a check for the compiler to make sure that whatever heading, header, function header, method header that you have specified there actually replaces the one that is specified up here. Otherwise, it's not a replacement for that method. You can't get rid of that. All right, now let's create Psychic Pokemon. Alrighty, there seems to be one called, I can't remember her name. Alakazam. Alakazam's a good one. Alright, so we're going to come down here in main and we're going to create a Psychic Pokemon. Psychic Alakazam. It's all A's, isn't it? Equals new Psychic, parentheses in parentheses. And he's going to attack. Who? I don't know. I meant to make that lowercase because all of our variables I like to make with lowercase letters. All of the class names I like to make with uppercase letters. Alright, so Alakazam.attack. And what is this attack? I'm just going to call it brain melt. Whatever. Sounds good to me. So when he runs now, he's going to use that attack. And indeed, we got a Psychic attack brain melt. All very good. Now we're going to create another Pokemon type, water Pokemon. Class water extends poke. And again, it has to override the attack method. Part of the contract. Since this is an abstract class with an abstract method, this subtype, this subclass has to implement every abstract method. So let's do so. Public void attack. Could have just copied it. And the last one, string S in parentheses. And this one's going to attack with a water attack, right? System.out.println parentheses quote water attack exclamation mark space in parentheses S. Alrighty, now we could create a water Pokemon. Water Squirtle equals new water, and Squirtle dot attack attacks with something called bubble. Sounds real sinister. There we go. All right. So it wants me to add my @override comment again. I guess it's not a comment if it starts with an @ sign. It seems like a good. I can find out what a keyword is that is preceded by an @ sign actually is. All right. I'm going to make a few changes to get all this code to appear on the same page. Sorry for squeezing it a little bit too much. I think that's just about as much as I can get on one page. Well, I can do that as well. All right. So there we go. We have two Pokemon. They're both of type Poke, right? But it's really a water Pokemon as opposed to a psychic Pokemon. Both of those Pokemon extend the abstract class Poke, meaning that they all have a hit points, and that every Poke is guaranteed to have an attack method. Hope that makes sense. Now, as I think about these Pokemon examples, what attack really ought to do is accept a second Pokemon as a parameter, because one is attacking the other, right? I'm not going to do that right now. Maybe that'll be another example. Okay, so back to our example here. Sorry, I paused it for a moment. Again, since it's important enough to talk about, why don't we go ahead and give these things names and create the hit points as we go. So the name ought to be another member, right? Protected string name, semicolon. And let's make a constructor that will set that name. What is a constructor? A constructor is a method that has the same name as the class, no return type, and is invoked by the new keyword to create an object of that type. So, and it should be public. Although since we're not allowing anything to create a Pokemon, specifically we could make it protected instead. But let's just follow the rule that in general constructors are public rather than confuse the issue. And so what are we going to do? Every Pokemon has a name, and every Pokemon has a hit point. In parentheses, open curly brace, right? And this dot HP equals HP, semicolon. This dot name equals name, semicolon. Now, is this actually going to work? It seems to me like it shouldn't work. And why do I say that? Because we have this constructor here. But I guess it's an optional constructor because, why do I say that? It's going to run anyways. No, there we go, right? Psychic extends Pokemon. It has to have a constructor. It has to have a constructor that's a name and an int, right? Well, let's see if getting that to work, scrolling down, is as easy as doing this. What is the name of our Pokemon? It's Alakazam, end quote, comma, and has 100 hit points. And it's still not liking that. Alright, I didn't expect that to work actually, but I want it to work. I want the electric Pokemon, excuse me, the psychic Pokemon, to be able to take a name and a hit points. And this Pokemon here does not have a constructor that calls that constructor. So we're going to make one. So for our psychic, we're going to make another one, public psychic. Why is it psychic? Because it has to have the same name as the class. And this one's also going to take a name. It's also going to take a hit points. But all it's going to do is call the super constructor, the constructor of the root class, the base class, the super class. So super, and then passing a name and a hit points on up to that. So when we create our psychic Pokemon, the constructor gets called. Whoops, put two close parentheses there. Constructor gets called, runs up here, runs that constructor, because that's what that keyword means. Call my superclass's constructor. Now, this down here is no longer an error. This one won't work though. It's funny that it doesn't highlight as a syntax error, but it does not run, right? Actual and formal argument lists differ in length. Water extends Pokemon. What it's telling us is that we need a constructor that accepts those two parameter types, a string and an int. And right now it doesn't. I'm going to cheat, copy and paste. Here's our constructor. Just going to copy it, paste it, and change psychic to water so that we can add it to the water class. Right click or edit copy. You know how to copy stuff. Come down here to my water class. After the add sign, after the opening brace, paste it, and we're going to make this a water type. See what I did there? I just changed that to match the class name. Now in order to create the Pokemon, I'm going to have to add a string and an int to where we invoke it, to where we create it. So Squirtle, end quote, comma, and Squirtle is not quite as robust, has 80 hit points. Now if we wanted to, we could modify our attack to have the name of the creature that was doing the attacking, right? So for the water Pokemon, we're going to modify this a little bit. We're going to say this.name plus quote space. We're going to do the same thing to the psychic Pokemon. Scroll up here to the psychic Pokemon. This dot name appended to concatenated plus quote space. Run it again. Alright, so Alakazam psychic attack. Brain melt. Squirtle water attack. Bolt. Alright. Looks like it works. Such that it is, right? The big deal is that we've introduced abstract methods. Since this method up in the superclass is implemented as abstract, that means it has no body, which means that every class that inherits from it, that extends it, has to actually implement that class. I should say has to override it, but it's really the first implementation of it. All right, now we can go and fully flesh this out, right? With getters and setters and, two strings and dot equals methods and stuff like that, but I think that proves the point. I think that, good enough for an abstract class. So let's scroll at the top and go down to the bottom so you can take another look if you want. Here's the abstract class. Here's the psychic class. Here's the water class. And here's our main class. This is the driver class with our main method in it. And if we were good programmers, we would have put the water class, the Pokemon class, and the psychic class all in their own files. So a constructor can call the constructor of the superclass using this syntax, the super keyword, and if it requires any arguments, pass them in between the parentheses. If not, if you're just calling a default constructor, you don't put anything between the parentheses. Now you have another way of calling a constructor as well, using the this keyword, like that. And if it requires any parentheses, you can do that. And let's give an example of that. This is just going to be a silly, dumb, teeny tiny example, so don't spend any time actually typing this in. Unless you just really, really want it. Alright, so I'm just going to call this class dummy. And it's going to have two different kinds of constructor. Right, it's going to have a special constructor that accepts a variable, right? So public dummy that accepts an int for whatever purposes. Who knows what it does with it? And then we're going to go back and we're going to add a default constructor, and all it does is call that constructor. So the default constructor is one that doesn't accept any variables. No parameter variables there. But it does call the other constructor, right? With the this keyword. Just like calling the super class's constructor with the super keyword. That would work just fine. Unfortunately, it has to also be the first line of code in the constructor. Now, if I did this up above it, int y equals 3, that's a syntax error. So, can we put a call to this and a call to super in the same method? I don't see how. So, for example, if I went up here to my water Pokemon and I made another constructor that accepted a double, right? Public water, parentheses, double, space D. It doesn't even do anything with it, so I'm doing, that, whatever. It would do something useful with that variable, or else why would we pass it in? So I do this and pass in a double, right? That's not a syntax error. You're allowed to call another constructor. However, calling the super constructor, that has to be the first line. Okay, so let's cut that and paste it on top. And now this is an error. So we have a problem because we cannot call both the super constructor and this thing's constructor at the same time. So if you had to do that, instead what you would do is you would make this a method. What do I mean by that? You would make some method that sets the value of that variable, right? Set D. And then you go and you'd add a setter for that variable. There's not one, right? So it's not compiling, but I could add one, right? Public void set D, parentheses, it takes a double. And it's, sets this dot D variable equal to that. Now that's not an error. I'm going to delete all that stuff because it's kind of cluttering up our example. So I'm going to delete this new constructor here, the empty bodied one. I'm going to delete the line that calls the setter, and I'm going to delete the setter itself. So what happens if you have a super constructor call into this constructor as the first two lines? But it doesn't work. And so if you really need it to work, what you do is you turn one of those constructors instead into a setter that sets those pieces of data. So using the superclass method from a subclass, if you call a method that's in the same class as the class, the reference variable dot prefix is unnecessary. You don't say super dot anything like that. You just say super parentheses in parentheses. Likewise, in an instance method, if you call a method that's in the superclass, you don't have to use the dot syntax. Well, instead of reading it, let's demonstrate that again. I might want to get rid of this example, but why not? We're going to make a method called greet, right? And the Pokemon says its name. Pika Pika. All right, so public greet doesn't take anything in here. And it just says hello. Whoopsie, I need to declare it as a typo. Public void greet, system.out.println. This is space end quote plus name, right? So we added a new method to the Poke class, and we're going to call that in the constructor. So I'm going to come down here, and I can just say greet, parentheses in parentheses, and it will figure out that that is a member of this class. Nothing wrong with typing this dot greet, and that's how I prefer to do it, if I spell it correctly. Because I like being able to type this dot, have it pop up a list of methods, but I don't have to. And if I was going to call greet from down here, which I'm not going to because this constructor already does it, right? So down here, the psychic Pokemon, if I wanted to call it, I could say greet right there. That works just fine because everything the superclass has, including the greet method, the subclass has as well. And it's giving me some kind of warning. Problematic call in the constructor, hint. You gonna tell me? Nah, of course not. Let's go Google that. Problematic call in the constructor, Java. What's wrong with overridable method calls in constructors? You tell me, Stack Overflow. Simply put, this is wrong because it unnecessarily opens up possibilities to many bugs. When the add override is invoked, the state of the object may be inconsistent or incomplete. So the constructor isn't done working yet, so we shouldn't really be calling methods inside it. So let's get rid of that. Same error up here, right? The object's not done, so we shouldn't be calling it. We can make the Pokemon class final. We can make the method greet final. We can make the method greet static. No, we couldn't because it's referring to a non-static variable. And we can make the greet method private. Well, will that really fix it? Well, lo and behold, it does. All right. Gets rid of the warning. That means that we cannot invoke greet ourselves from the driver class, from the client class. I don't really like that answer. Make the Pokemon class final. And now we get an error down here. What did that do? When you set final, well, apparently you can't make a final abstract class. And we're going to get rid of that. That was not a good fix. Make the method greet final. That seems to be a good fix. Why don't we Google up what it means to make a method final? What is a final method, Java? You can declare some or all of a class's methods final. You use the final keyword to indicate that the method cannot be overridden by a subclass. Quite the opposite of an abstract class, an abstract method, quite the opposite. This method here has to be overridden, it has to be implemented in the subclasses. But we cannot create a greet method that accepts no parameters. We cannot override that in our subclasses. All right, it gets rid of the warning. I don't expect to be customizing, adding individual overridable greet methods now down in the psychic and in the water class. Time to make a few notes. An abstract method is a method with no body that must be implemented in any class or in any non-abstract class. Just remember that. In any class that implements, that extends, inherits from that superclass. What is an abstract class? An abstract class is a class with an abstract method. All right, the final keyword, or a final method used on a method, indicates that that method cannot be overridden. Now, when I use the word implemented, I should say overridden, right? How about I tack that on as a parenthetical comment? Implement, in this case, means providing an override method. All right, I can think of another note. The driver cannot instantiate an abstract class. It can only instantiate, create a new class, a new object from the subclass. It can only create a new object from the non-static subclass. Another note, @override is used to mark a method in a subclass that overrides a method in the superclass. Now, every object in Java extends the so-called object class, just like it had this word, extends object. So that's just a given. Apparently it's not a syntax to add it there. You could put that there, but it'd be kind of silly. Silly because it does it automatically. So what does that mean? The object class gives us a few methods. If I type in this dot down here, it's got a whole bunch of things. Well, you can't see that. It's got a whole bunch of methods that we did not implement. It's inheriting all of these from the object class. And we could Google up what they all do if we wanted to. And then we're getting a few that are actually part of our class, like the greet method. Greet's sitting there right there. And the attack method. Most of these are inherited from the object class, including our friend toString. We can customize toString so that it actually prints useful information out rather than just printing out the name of the class. And .equals, you want to compare two Pokemon, make sure that they have the same name and the same number of hit points or whatever, however you indicate that they are the same, you could override the .equals method. Let's get rid of that line. Alright, I don't think I've done anything stupid so far. By that I mean anything I want to delete from the Pokemon class. I think I'm happy enough with these changes. I think I might want to add a comment to this one. Attack method must be implemented overridden in a subclass or in any non-static subclass of this class. And here we're going to add the comment, just again like my notes up there. Final means that this method cannot be implemented / overridden in the subclass, in any subclass. All right, so why do you use abstract classes? You use abstract classes to kind of create a contract, and the contract is that any subclasses will have that method. It's impossible to make a Pokemon subclass that does not implement attack, which is useful information for polymorphism. What do I mean by polymorphism? Polymorphism is when you have objects that are treated in different ways based on their types. For example, we could create an array of Pokemon, either psychic Pokemon or water Pokemon, and we could call the attack method on each one of them, and it would call the correct attack method. Show you what I mean. Yeah, that dummy class. All right, so I'm going to create an array of type Pokemon. Poke, square brace in, square brace, array equals new Poke, and we're only going to have 2 in it, right? And so array element 0 is equal to Alakazam. And array subscript 1 is equal to Squirtle. Now, since it's an array of Pokemon, this array doesn't know the difference between a psychic Pokemon and a water Pokemon. It thinks they're all just Pokemon. So if there were any specific methods that were specific to Squirtle, it would not be able to call them, right? Because it wouldn't, if the water Pokemon had that method but the psychic Pokemon did not, right? Then what would it be, what would it supposed to be able to do when I called array, 0 dot and whatever it was? Like we wrote a splash method, right? The water Pokemon might have a splash method, but the psychic Pokemon absolutely is not going to. So it doesn't know what that is. However, we can call any methods that are defined in a superclass or that are abstract in the superclass, including attack, right? So we could say array 0 dot attack, or we could write up a for loop, whoopsie, whoopsie, whoopsie. And this attack, I don't know what this attack is going to be. It's going to be a generic attack. I have no idea. And it's going to do it for 10 points, right? And then array subscript 1 is also going to do a generic attack, right? For another 10 hit points, right? Ooh, look at that. Oh, because the attack doesn't specify the number of hit points. My mistake. So remove the comma 10 from both of these, and we're good to go. And so when we run it, Alakazam does his generic attack, Squirtle does his generic attack. Now that's probably not the best example of making a polymorphic method, because it looks like we're supposed to be passing in some kind of data here. But honestly, what we would do is we would make these attacks members of the classes, right? So, the attack method should go and pick a specific attack from the list of attacks that Pokemon can use. This is polymorphism. Dot attack is calling one method in one object. It's calling a different method in a different object, even though they have the same name, right? But water Pokemon have that implementation, their own custom implementation of the attack method, and psychic Pokemon have their own custom implementation of that attack method. So that's polymorphism. Polymorphism is when objects are treated the same way, but the functionality is different based on which type they are, right? It's the same method name, but since that method is implemented in both of those, and if this was not an abstract method or a method that could be overridden, then we wouldn't be able to do it because the compiler has no idea. So the only methods that could be used by that code are things that are defined in our Pokemon class without doing some kind of deep trickery, right? So we can't call methods that are not defined as part of the superclass when we're treating them like this, when we create an array of the superclass. Now we'll give another example of this at a certain point, where we stick a whole bunch of objects in an array list, and then they exhibit polymorphic behavior based on that. So you can make a call to the superclass constructor. Default call is just the one with no data between the parentheses. Method overriding is when a subclass has a method with the same name and the same parameter types as a method in the superclass. Just like attack, right? Got the same name and same parameter list. And we did an example of that in our last lecture as well. So if the subclass contains an overriding method, the object of the subclass will use that subclass's method and not the superclass's overridden method. So say the greet method was not final, and we went and we overrid it inside the water Pokemon class. then when we call to greet on a water Pokemon, it would call that specific custom method, the override method. And if we called it on the psychic Pokemon, which did not have its own separate specific custom constructor, its own override for the greet method, it would call the one from the superclass. So if a subclass and a superclass have methods with the same name, same parameter types, but different return types, that's a compilation error. Right, if you have two methods with the same name and the same parameter types, but they return different types, then how's the compiler supposed to know which one to hook up to? The final access modifier, you want to specify a method definition that cannot be overridden, use the final keyword. So we've covered two basic class relationships. Aggregation and composition are has-a relationships. Every Pokemon has a tag. Every Pokemon, every geometrical shape has an XY coordinate. But inheritance is a relationship, because a water Pokemon is a Pokemon. And a psychic Pokemon is a Pokemon. In the real world, it's fairly common to have aggregation, composition, and inheritance relationships in the same program. So these are has-a relationships. And they don't give us the answer to this question, and I'm not really coming up with one. I guess we could say that manager and salesperson would both be inherited from an abstract class called person, because they are both people, right? And why would we do that? So we can put the traits that are common between them in the superclass. Every manager has a name, every manager has a salary or something like that, a birth date, and so on. So you could create a superclass that contains all the information that's the commonality of these two. I'm skipping the card game lecture. You can look at it. You're kind of doing yourself a disservice if you do not look at the entirety of the PowerPoint. Skipping the grid world as well. And our critter class. Hey, that's funny. They created the same name as we did. We're going to be coming up a little bit more on the idea of inheritance. And we're going to be broaching the topic of interfaces. And interfaces are necessary because a class can only extend or inherit from a single class in this language. Meaning I cannot say that a Pokemon is both a Pokemon and a critter, right? Might make sense to me that I should be able to do that, but I can't. And C++ allows me to do that, but it also creates a whole bunch of complexities that the developers, the creators of Java decided to avoid. But what if I really need my subclass to extend two separate classes? Well, instead what you do is you have one subclass that's one superclass that's the honest to goodness superclass, and then you implement the other one as a so-called interface. And the interface is something with some abstract methods that you can override. And your class can extend, it can implement as many different interfaces as it wants. So it's kind of inheriting. Well, it's inheriting everything that's in those interfaces. We will talk about that more in another lecture. I think we're pretty much done with this lecture since I'm skipping these two examples. So what type of thing is used as an example for a composition hierarchy? It showed a human body, and a body is consisting of tissues, right? Muscles and brains and whatever. What word indicates that a class derives from another class? Extends. What is it called when a subclass has a method with the same name and the same parameter types as one in its superclass? That's overriding. What access modifier can be used in a class name to prevent someone from making a subclass from the existing class? If you mark a class as final, it means that this class cannot be used as a superclass. Not really sure why you'd want to do that. And which of the following is not a class? And okay, well, whatever. All right. So we're done with that chapter. So I think that means we're done with this lecture as well. Can I think of some homework that I want to assign for this? I think I should choose not to. I want you to be working on your projects.